Hello, everyone. Thank you for joining. We hope today's webinar is an exciting topic. I sure was excited to put this together and work with a bunch of colleagues and partners on this topic. So I think this is, one of the next chapters in this exciting story of artificial intelligence. So today's topic is AI inference. And really, this is about where AI goes into production. So beyond development, training, prep, prototype, but into the hands of real practitioners doing real jobs. So this is pretty exciting. My name is Michael Boris. My email, as you can see, is m_Boris, B-O-R-O-S, at Dell.com. And I'm on the Strategic Alliances team for the Workstation group. And my responsibility is basically everything. I work on things around artificial intelligence and high-end analytics for workstations here at Dell. Pretty fun place to be, pretty fun topic. And some of that will be woven in here. But to be clear, today we're not just talking about workstations, right? We're going to talk about a soup to nuts AI. So, because when it goes into production, right, really we're going to briefly touch on a little bit of development and training, mainly to illustrate how it is related to deployment and inference. So a little bit about how we got there and a little bit about some platform considerations so we can compare and contrast with inference between, kind of development and inference. And then we're going to talk about a little bit about servers, inferencing on servers, platform considerations for server inference. Then we'll talk about inference on workstations. So we're seeing a lot of growth there in this area. And, again, this is not just development on workstations, but this is real inference on workstations. So putting in the hands of these other practitioners who are using it day to day after the developers have turned it over to them. And then we'll talk a little bit about some use cases for that AI operations, because it's kind of a new thing, but we think it's exciting. And just to be clear, this is kind of, a higher level intro to this webinar. We're going to have deeper level webinars we'll be working on with our partners like Intel that are going to deep dive into development considerations, different APIs and what have you, and including some really, really exciting stuff that's coming here in the next just couple months. So please, stay tuned to this series. This is one that's going to feed into those topics. But I think there's some really good stuff happening in the near future, especially a lot of really good stuff around inference and just in general. A lot of movement, in platforms, APIs, and development. So, please come back and check out some of those topics. So real quickly, you guys have probably seen this a lot. I'm not going to spend a lot of time on this. I'm just going to fly by this real quick so we can refer to it as we have our subsequent discussions. Why are we here? Why are we talking about AI? Why are we talking about all these platforms? Really, as I see it in my time in the industry, it's kind of two innovations that have enabled the development of a new one. So we've got big data. We've been, in my career for, 25 to 30 years, been talking about what are we going to do with all this unstructured data? Well, now we know. We have an answer. And that's really powerful because this data is the foundation of AI. So we can now correlate, structured data, unstructured data, semi-structured data. It's pretty powerful. And as you'll see in a lot of these use cases, that's fueling a lot of this, AI, a lot of these AI possibilities. We've also got new types of infrastructure. So we've got accelerators, and we'll talk about, I've got GPUs pictured here, but we'll talk about lots of other types of accelerators out there. And this is another thing, right? These are new compute architectures that are really enabling us to do things more parallelized. We're going in some cases from handfuls of cores to, many thousands of cores in a chip. That's amazing. And the combination of these two things have enabled us to make advances in algorithms that we only thought theoretical before. I had a colleague I worked with for years who got his PhD about 20 years ago in artificial intelligence. And he said back then, their aspiration was that they wanted to have infrastructure that could more or less mimic the brain of a fruit fly. Well, we've gotten there now. And that enables us to do some pretty exciting things like this. So machine learning has been with us for decades. Nothing really dramatically new there, although the methods it's much simpler now than it's ever been. And as we'll see, we certainly are not throwing machine learning out with the baby out with the bathwater, right? And really deep learning is advanced machine learning. But in essence, in machine learning, what you want to do is let's take a simple problem like what is a dog, right? And what you want to do is go through a process called feature extraction. So if I look at a photograph of a dog, a JPEG, and I break down that image, or a video, an MPEG, or what have you, how do I programmatically go in there and identify characteristics of a dog? Well, dogs are hairy. They've got 4 legs. They've got floppy or pointed ears. They've got, you go through and you find all these things. That's called feature extraction. You express them through code. And then we go through a process of classification, right? The algorithm goes through and then it kind of spits out, is it a dog or not a dog? And you could tell, I mean, the difficult part in that process, especially for something, is kind of tedious and difficult as like multimedia data, as we'll see, is that feature extraction step. Really difficult, right? But very smart people have been making it work for a long time. Well, now that we can mimic the brain of a fruit fly, we no longer need to go through that feature extraction step. So rather than go there and explain, programmatically with code what a dog is, right? We teach a computer what a dog is in the same way that I've taught my 4 children what a dog is. I look at a picture of a dog and I say that's a dog. I look at a picture in a book and say that's a dog. I look at a dog on television and say that's a dog. I look at a dog in real life and say that's a dog. And sooner or later, I've given them enough examples, right? With this automated feature extraction where I just give them snapshots. Here's an example. Then my kids go out and find other examples of dogs. Well, that's the same thing that we're doing programmatically. And this is very important as we'll learn that there are different architectures, but it's the ability to do this feature extraction. That is causing this dramatic revolution in artificial intelligence, right? The ability to mimic this brain of the fruit fly, where I don't really need to know how to express and code what a dog is. I just give it different examples of a dog, and then the computer goes out and finds more. So let's talk about why that's important for development, right? And then we'll get to the inference. It's coming, trust me. But we need to kind of tie to this as it shows the architectures that, if we're dealing in artificial intelligence is a broad range of things. Some people consider it, kind of advanced analytics. Some people, of course, it is machine learning. And then it is this new area of deep learning. Well, these are very different, right? You start off with analytics. You're more or less dealing with structured data, not a whole lot of data, not a whole lot of cores needed, not a whole lot of parallelism, right? Not a whole lot of threads simultaneously. Then you get to this concept of semi-structured data, right? Basically dealing with metadata you've generated about data. And that is, yes, okay, you're dealing with more cores now, more data, a little bit more complexity, and and then you get up to deep learning, which is, again, you got to mimic the brain to this fruit fly, and you got to be able to just plop these things in there and have it automatically go in there and do this feature extraction. That step is computationally extremely expensive, especially with a whole lot of data as you get to all these different data types. So you can see computationally much more throughput required, many more cores, lots of concurrent calculations, lots of parallelism. So there's an expense there, even though it's very cool and lets you do a lot of fun stuff. But like everything in life, it's not really free. So now, and the reason I'm bringing all this up is we go there and we talk about inference and we talk about putting things out in the field. We need to think about the kinds of data that we're dealing with, what we're doing inference on, and that will influence the requirements for systems doing inference out there in the world, because a lot of them we think biggest, baddest in the world, and they're really not. Looking at this, right, we start off with kind of structured data, right? So structured data, recommendation engines, cross-sell, upsell, demand forecasting, churn reduction, failure, but all that kind of stuff, right? That stuff is, if it's structured, it still may be better off in machine learning, because you can go in there and that feature extraction step might not be very difficult to do programmatically. Same thing with other textual numeric data, right? So social media sentiment analysis, clickstream analysis, all this other stuff. Textual numeric data, that may be very easy. You don't need to build that fruit fly or bigger brain computationally. Maybe you could do all that stuff, right? Quite simply, with machine learning, right? And there's good tools that are growing all the time. They simplify that feature extraction process. Now, there are some examples of textual and numeric data that perhaps are better off with deep learning than machine learning. If you're dealing with foreign languages, right, language translation, and you have a data scientist or developer maybe that doesn't understand Mandarin or Spanish or French or 50 other languages, deep learning may be their friend. They can go find examples, again, snapshots, and just put it in the system. Here's an example of a fraudulent transaction. Here's another example of fraudulent transaction. Different languages, go out and find more fraudulent transactions. Find the similarities. Same thing with chatbots, right? Sometimes when we're trying to kind of mimic this behavior, those are examples where maybe deep learning can come into play. But certainly, anything dealing with multimedia, sound and speech, customer services, text to speech, all that stuff, best off with deep learning. Images and video, right? Object recognition, video captioning, geospatial, quality testing, all this stuff, right? This is all stuff that is perhaps better off with deep learning. And I say that because when we look at the underlying architectures between here, right? If we're dealing with the kind of more machine learning approach, we potentially are dealing with systems that could be fairly well served if they're CPU centric. If we're dealing with a deep learning approach, especially when it comes to the development and training, that is the almost exclusive domain today of GPUs, especially on the development side, right? And we'll talk about that. But that's why you get these big systems stood up with very big, power-hungry, powerful GPUs, and they don't necessarily make light work of it because it's really hard work, but comparatively. So let's now talk about this. So if you are a data scientist or developer or somebody standing up these applications, let's talk about this step going from kind of development to deployment to inference, right? So the first thing you've got to do, and there's no getting around this, that's why data is still in the name of their title, is they've got to spend time doing, the data acquisition, data cleansing, preparation, all that stuff. Data scientists that freely admit even today that this is where they spend 80% of their time. Once they have that done and they have that data foundation, right, then they're going off and they're going to the next step, right, which is essentially they're going to go identify algorithms and do evaluation, parameter searches, all this other stuff. And then they go out and they deploy it in the real world. And that's called inference, right? So you mess with the data, you then find algorithms and you train it, and then you go out and you deploy it. All right. So very briefly, for that development piece now, let's talk about the platforms that they'll use. As we talked about, so CPUs, and all these systems will have CPUs. CPUs are necessary, is certainly helpful for data manipulation, right? Still, the operating system goes, and, a lot of that stuff is OS bound, it's whatever, it's dealing with lots of different, maybe different ETL tools or what have you. Still, CPUs, for the most part, although there are some use cases in some situations where GPUs can make light work of this stuff. So, it depends, your mileage may vary. But in a lot of cases, CPUs still are the workhorse upon which that 80% of the work you rely upon. And then also for machine learning, for a lot of machine learning. This is why it was important to differentiate machine learning and deep learning. If it's not deep learning, if you're dealing with a lot of that textual and numeric data, you are that you're okay with doing that manual feature classification or whatever feature protection. You can do that with a CPU, and but the thing is, it's rarely good at. We'll talk about this, but for development of deep learning, right? For basically training, CPUs today are rarely good for that. What is really great for that is a GPU. Right, namely in this day and age, NVIDIA GPUs with the CUDA architecture. Right, they sell a deep learning and training. Absolutely, that's what you're going to need. You're going to want a bunch of big, fast NVIDIA GPUs doing that stuff. They're also good for some machine learning. Right, in some cases they may be overkill. In some cases they're great, and they can also be tuned in some situations for the data pipeline. So yes, there are and plenty of examples. That NVIDIA will give and other folks in the industry will give, where they have real big speed ups, accelerating GPUs for that data pipeline. But again, things go back and forth. As we talk about, there are some really big advances that Intel's been making too. I mean, competition is good in the industry, and we at Dell are a partner. They're both great partners. And NVIDIA and Intel, as we'll talk about, is doing some great things too around accelerating that data pipeline as well as other operations. And then there's this new generation of these new, this specialized silicon that we're starting to see in AI, right? FPGAs, ASICs, all sorts of specialized silicon. The picture there, that's Habana Labs, which is an acquisition that Intel recently made. But the thing is, amongst these systems, right? all this specialized silicon, it's really good for specialized jobs. So if you're doing something like, you know, video analytics, image recognition and video, that's, there's a number of players doing that right now. Intel's got a Movidia solution, which is great for that. There's a whole bunch of examples where you find a specialized use case, right? Even for development, and this silicon is very useful for it. So these are all things that should be considered for your data scientists and developers on the development side, right? CPUs, GPUs, and all this new specialized stuff to keep an eye on. So now we've talked about developing, and by the way, there are a number of other webinars you can look at. I will provide a couple links in here to some that we've done in the last month or so, where we spent a great deal of time talking about what developers, different systems, platform considerations that data scientists and developers should have on their minds when they're developing AI solutions. But now let's get to the topic of this presentation, which is deploying AI. So let's start off by talking about deploying on servers. Okay, so remember what we just talked about, where we have the, all the development activities, all that stuff under the green box there. So the data acquisition development, again, 80% of the time, cleansing and preparation, all that stuff. Then we get to the model development and training. And then we get to the deployment, which is inference. Now, of course, when you are deploying a trained model, and in some cases right now, one of the trends that we're seeing is some organizations who perhaps aren't even training their own models. There are a number of trained models out there in the open domain. There are organizations right now selling trained models where they've gone out there, they've acquired all the data, they've done the heavy training, they've got the big clusters or massive workstations that are going off there, they're crunching for days or weeks or months, and they're training these models, and they're making those trained models available. Now, of course, the good news is that if you adopt these models, right, and you embrace them and you run with them, you of course don't have to get burdened with all that training, but you still do have some ability, of course, to refine and customize. So the smart speaker in your home, same principle. You can train that speaker over time, right? What you're doing is you're essentially layering over, an inference, pre-trained model. But this is kind of a similar thing that we're seeing right now. But the cool thing about this deployment phase, and this is what we're talking about, is when you deploy on these servers, workstations, or the cloud, right? You can deploy this everywhere. Again, it's now out in the wild, right? You've been developed. This is where you're starting to, realize the return from your investment. So let's talk about this briefly, development to deployment. Artificial intelligence, it can be said, and I really love this phrase, is a team sport, right? This is how it works. So in AI, we've got data scientists and developers, and we'll talk about this. This is even a growing group now. Now you're even broadening out to analysts, other scientists, traditional business intelligence professionals, even DBAs now. DBAs now are deploying machine learning algorithms in some cases over their tried and true operational or transactional databases. So we're seeing all sorts of stuff like this. So it's a broadening. There are more folks developing today. And of course, they do these classic activities, model development, training, whatever, and they'll develop on workstations, servers, and cloud. Now, we've got another presentation that we'll point to from this link, from this one, where we'll tell you all about the benefits of developing on a workstation versus, some of these other platforms. But, you should pick what suits you. And then once you've passed this development step, then you get to deployment. Now, what we're talking about here today is there are three major types of deployments, and there are different considerations for each of these. So this is really what we're going to talk about. We're kind of getting to some of the heart of this presentation today. But the first area, what in this deck is calling AI services, is really when you're inferencing, right? You're deploying on either cloud or servers, right? So this is AI services. This is the classic model. I'm going to develop on a workstation or on my server or in the cloud, wherever, and then I'm going to go off and I'm going to deploy it somewhere on a server or on the cloud, and then that's how everyone's going to access it. That's how they're going to get their goodness. The next step is inference on workstations, right? Everyone's kind of, this is a newer thing. We're seeing more instances of this. In many cases, you have a workstation that already had an important day job. It was already doing something else, and now it's taken on some fairly heavy artificial intelligence inference capabilities that are being integrated in with its work. So we'll talk about what that means and those considerations and what that looks like. And then the last one is really the edge. And everyone thinks of the edge as being, the intelligence is going off all the way to this thin edge to these small devices, where the reality is, we all know on the back end, and what we'll talk about is it really looks more like a classic, like one of those AI services deployment, or even in some cases, an AI operations deployment. We'll talk about where intelligence lives on workstations and it gets deployed also on the edge. But there's really something backing it up, but we'll talk about it. So let's start off now briefly by talking about AI services. So when you're going to deploy on the cloud or on servers, what's happening ultimately is IT or data or somebody like that is still controlling it, right? But it's going to be used by all. So as we'll see, when people talk about AI everywhere, this is what's happening. So everyone's logging in from their phones or calling in or whatever, and laptops or whatever, and they're accessing these services, right? And really what's happening today when you're deploying these services, you're either building new services, or in many cases you're upgrading existing ones. And we're seeing a lot of this right now. There's a service that's been up for a while, and now you're just adding machine learning into it, or in some cases deep learning. And what's required for here is really server storage, networking under cloud, lots of architectural requirements. But let's talk about that. So first off, this path from development to deployment, again, organizations use different types of devices or systems to do this. So platforms, you can start off with, many organizations find out that a workstation's best, because workstations, the data is local to you. It's your own sandbox. You can do whatever you want with it. You don't have data center restrictions or data center utilization hours. You don't have cloud, lockdowns and requirements. Artificial intelligence today is kind of the Wild West. So if you have a workstation that's got the horsepower to do a lot of work, and you can do just about everything you want with it, in many cases organizations are finding that's the best way to develop AI. So you do your planning, experimentation, development, and initial prototype on a workstation. And then you go off, do later prototypes, production, put to scale, and you do proliferation, right, on either a server or the cloud. And then you go back to do the revisions, you go back to the workstation. Point is, it's kind of a wheel, right? And there's, the ability to kind of go back and forth is nice, right? Make workers more productive, get things run out sooner. But there's something really important to know about this, right? As we go to these servers, going back and forth from workstations to servers, or different types of servers or cloud providers, one thing to bear in mind, right? Again, realize in many cases they're standing up new services. In some cases, they're upgrading old services. Not all servers are created equal. Many servers today aren't really built, for example, to accommodate GPUs, right? If it's an enterprise server, in many cases, it could be scale up, could just have a big database on it. Maybe fewer, fatter cores, right, with no acceleration, things like that. So that's a very big consideration as you're going out there to deploy on servers, is what is that like? So for AI server deployment, and again, we're talking about inferencing on servers, what are your options? So GPUs, of course, are an option, right? The thing to know, sometimes they can be overkill for inference. Having said that, NVIDIA, for example, has a GPU that's built especially for inference. And that thing is probably pretty darn good for inference. So if you have a server that can accommodate that, that's a good option. But in some cases, again, maybe the servers that are set up, they're not accelerated, or they don't have that many slots. Maybe they have power, heat, or space requirements. So there are a lot of issues. But GPUs, of course, don't get me wrong, they are the de facto for AI development. But when it comes to actually deploying that inference model in the wild, and in some cases it might not make the most sense right off the bat. So then there's another option, right? Which is FPGAs and ASICs and specialized silicon. That is a great option in many cases, but it's new and it's kind of they're just coming around. So but keep an eye on that space, right? Because there's a lot of stuff coming down the pipe very fast. They sell it specialized inference. So if you're doing something, like I've got that, a Movidius card from from Intel is going to be outstanding at video analytics and very efficient. That's the Habana Labs card I have there to the left. There are cases where they're very efficient for doing, but that's, again, they're not kind of general purpose, where like a GPU using CUDA will be doing lots of different types of things. The idea is that they'll excel at one specific type of activity. So that may or may not be useful for your server environment. Because, in many cases you could be, for example, correlating between multimedia data, textual numeric data, a bunch of other things. And so some things maybe that specialized silicon would be good at and other things it wouldn't. So that's something else to take into consideration. Now, another thing, and we'll talk about this and we will have a subsequent deep dive on this, is using CPUs for acceleration. So, CPUs are, look, they're ubiquitous, right? They're everywhere, right? The important thing to know is not all are created equal. So the newer Xeon CPUs, for example, have some very interesting technologies around deep learning inference. So DL Boost is a great technology to start looking at. Open Video, really good for things like video inference and stuff like that. There's technologies coming in. Poke around Intel's website and look at One API, which is really shaping up to be a very compelling story. And by the way, we are going to be working with them on a webinar in the near future to deep dive on that. But you're actually seeing now some very interesting results. So on the server side, the newer Xeon processors, a high-end one, can accelerate deep learning inference by about 30x, 30 times, not 30%, 30 times. And on the workstation side, you get about half that. You get about 14, 15 times acceleration. So that is, specialized cores within the processors that are built for inference. So with that kind of power, that enables you to do things like benefit for inference, right, for deployment, by some of the capabilities that give you almost GPU-like performance, but without needing the specialized hardware. Again, not saying that GPUs aren't the right call. It's different, but in a lot of data centers, sometimes flexibility and availability are very important. So this is absolutely something that warrants looking at. And this is a slight dive into DL Boost. They're built to run complex, AI. Basically, it is deep learning inference, right? And here's the cool thing. And again, 30x faster on servers, 15x faster on workstations. Here's the cool thing, right? You don't need to do a whole lot to start to take advantage of this because they've already got the most popular frameworks, PyTorch, TensorFlow, MXNet, Paddle Cafe. They've already got that stuff already compiled, optimized, and ready to go. So you can leverage these frameworks from Intel to plug into. And, you're likely to see continuing popularity on this. And we'll talk about that for a bit. But this is why, stuff like this is why, most of the analysts see that inference will continue to be dominated by CPUs in the near future. But again, GPUs on training and other things. And again, they're really useful for, tasks like image recognition, speech recognition, recommendations engines, that sort of thing. So do yourself a favor, check out DL Boost. Also Google around, look at OpenVINO, and look at One API. These are really interesting technologies that will allow you to unleash capabilities inherent in your newer CPUs. Then there is the edge. So everyone's talking about this. I just bought a new ceiling fan and a refrigerator, both of which are apparently smart. but I don't expect them to have, workstations or supercomputers built in them. Of course, they're relying on the network. And here's the point, right? That those thin edge devices are never truly autonomous. They're always relying on something on the back end. And we'll even talk about situations where workstations could be the things that they're relying upon. But that's the important thing to think about with edge devices. So really, in essence, looking at an edge device for server deployment, other than, and I don't want to trivialize this, other than the literal deployment on the device on the edge, which, we're not going to discuss today. There are a whole lot of examples on that. There are a whole lot of people that are much better qualified to talk about, deploying on a drone or a smart speaker than I am. But what I will say is, having been involved in some of those projects, is, what's on the back end is equally, or in some cases, more important. So now let's talk about deploying AI on workstations. So this is something that is not often discussed, but the idea is that it's not the thin edge, I'm not deploying on a server or the cloud. It's in the middle, right? I'm deploying on, a workstation, right? A powerful desktop or laptop. And it's going to be used by a broad range of professionals. And they're going to be using it, right, to increase the effectiveness in their existing job. And they're going to be doing this, again, it's going to be on mobile or fixed workstations, so laptops or towers, desktops, sometimes small form factors we're starting to look at. So, and they're doing inference on this. And the idea here is that they're multi-purpose, right? They kind of they'll have a day job, they'll have something else that they're doing. In many cases, that requires quite a bit of horsepower, and they're layering inference on top of it to do that day job better. We'll give you examples. And today, analysts are saying that it's around 70% of the market today for inference is actually done on CPUs. Projections are that by 2025, we'll be looking at about 50% CPU inference and about 40% on some kind of specialized silicon. So that's what we're seeing come by. So there are some platform considerations for deployment on AI. So the first thing, GPUs for inference, for workstations, these are workstations, after all. Some of them will have many of them will have GPUs. A lot of them will have GPUs. But there's a lighter GPU requirement for inference than for development and training. That's the first part. So, but in many cases, again, the workstations might have a day job that requires a GPU as well. So that's important. But the other consideration are power, mobility, thermals, and other considerations. They have to come into play. So, everything needs to be looked at, price, everything needs to be looked at. So in some cases, that's why sometimes, even if there are GPUs, some organizations look at different approaches for some types of inference. One of them, again, this is an area where specialized silicon is starting to make some sense. So we see, again, I'll mention Movidius for video analytics, where you can have a, very small wattage M2 card that competes with cards that require, 20 times as much power. And that could be interesting in some situations, or significantly more power. But that could be very interesting, because in many cases, power and thermals, all that stuff matters, something small and specialized. So this is why we're seeing analysts are projecting that this specialized silicon will, have a significant impact on AI inference deployments in the next few years. And then, of course, there are tried and true CPUs. So they're ubiquitous. They're everywhere in some form factors. You can't really fit anything else other than a CPU, or not a lot more. And they can, today, I put this number down again, 14x to 15x. Arguably, it's 15x. Point is, they have cores that are specialized. In every subsequent generation, you're going to see more of these cores dedicated. And they're doing nothing but getting faster. So I say watch this space. Watch this space as a register for webinar very soon here. We're going to be working with Intel on a couple webinars where we're going to talk about a lot of details on the latest generation of inference capabilities and other capabilities that are inherent with the new Xeon processors and new APIs they have coming down. So there's a lot of good stuff really happening, especially around inference. But there's a lot of good stuff that actually, and the reason we start off talking about development is it can control kind of what you're doing from that development phase to the deployment phase. So very quickly, and this is question that we get a fair amount, what's a workstation? Because we're talking about deploying AI on a workstation. Are you just talking about deploying on a PC? Well, workstations are systems. They're built to perform predictably. They're built with the highest performance components and reliability components. And they're really, the main point about a workstation is it's optimized specifically for the software running on it, for the job that it's built for platform, for people whose time is important, whose jobs are important and time is valuable, right? So if you don't want to mess around. So quality, when we say professional components, what do we mean? We mean Quadro RTX GPUs versus the GeoForce stuff. Much more reliable, a lot more memory, much better job at doing AI workloads, things like that. So Quadro GPUs are this default standard for doing that, especially if you're doing development or training. Absolutely. Xeon CPUs, as we talked about, really useful for the reliability and doing all the data pipeline movement, but also very useful for inference, as we were showing, more memory, faster storage, all this stuff. Boom. And then also this, right? Which is, you've probably seen this before. But if you ever get one of these blue screens of death, or if you get a kernel panic in Linux or what have you, now this is really important both for AI development and also for deploying, because as we'll see, a lot of these jobs where they're going to be using AI, where systems are deployed on in the field, those are mission critical situations where you don't want those systems to die. So failure is not an option. And this is why one of the benefits of deploying a workstation is you get to have ECC memory. So you get to have memory that avoids those blue screens of death, which are caused by hard errors. That's when a memory bit fails. You also get ones that avoid soft errors, and that is when a bit is flipped. So instead of it being $1 million, it says $1,000 is owed, that sort of thing. ECC is a technology that you're probably familiar with if you're coming from the server side, because you wouldn't dream of deploying a mission critical server without it. Well, what we're saying is that these workstations for developing AI and for using AI, for operations where AI is necessary, perhaps these are important enough that this should be a consideration. The way to get this benefit, you don't just get it by popping in ECC DIMMs. That's part of it, because you've got an extra chip in there for parity. But the other thing you need is you need a motherboard that supports it, you need firmware, and you need a CPU, namely a Xeon, that supports ECC memory. So this is all really important for the development and deployment, inference of AI. We go a step further with Dell workstations, which we think would really be useful for these mission critical AI deployments, which is that we have a technology called Reliable Memory Pro, where not only do we identify the bad bits, but we'll actually map around them in much the same way that you may be familiar from, back in the days when you had, spinning drives, maybe you still do, and you find a bad sector, the way that you can map around that. Well, that's really the same thing we're doing here. So you don't have to remove the DIMM, you don't have to order a new one, you don't have to bring your system down, you don't have to do all that stuff, wait for days, and you know that we're just going to map around it, work around it, and support it. So that kind of reliability, we think, is important both for the development of artificial intelligence, but also deployment in these mission critical important jobs. So now let's talk about these mission critical important jobs. Again, we're talking about areas where you would actually, use cases where you would actually deploy artificial intelligence on workstations, ultimately in the field. So here are a few examples. IT operations, DevOps, we'll talk about that. Radiology, telehealth terminals, manufacturing operations and safety, public safety, utility operations and safety. So let's start off with AI operations, hence previously known as DevOps. So DevOps is kind of changing now. If you're in the DevOps world, or you know folks there, people that work in a NOC or what have you, you'll see now that the hottest term now is AI ops, right? So we're changing, right? And the idea here for them is that, of course, many of them are still going to do this kind of work on servers, but in a lot of cases, those servers are, maybe they're down under a denial of service attack, or there are networking issues. A lot of things can happen where maybe you can't get to part of the data center. So sometimes having a nice big workstation that you can really ingest all this data from all over, right, from SNMP data or change CMDB data, or you name it, log data, Splunk, whatever. Bring data over from the world, right? Put it on your system, massage it, or maybe you're the main DevOps person and you're going to deploy this to your team where they can all have, these kind of solutions stood up, and then you can actually experiment. Use AI, do things like root cause, predictive failure, pattern recognition, threat mitigation. You could do all that stuff locally on your system by ingesting the data from everywhere. So that's a pretty interesting use case for AI workstations. And by the way, bonus use case, almost the same kind of skills and requirements are needed for cybersecurity. So we're seeing interest in cybersecurity workstations as well. Radiologists is another area. In the last 10 years, the number of CT scans and MRI scans has increased by about 1,500%. Also, each of those scans now has between 10 and 20 times as many images as it did 10 years ago. As a result, the average radiologist gets about 3 to 4 seconds to view each image. So that certainly leads to fatigue. So the idea here is to use image classification and pattern recognition, right, to reduce the signal to noise ratio, where these radiologists don't have to look at thousands of images perhaps, but they can focus on hundreds of images that they can spend more time on and really put their expertise on. So this is a useful use case. We're seeing interest in this. AI is getting much better at doing this. There's been a lot of challenges out there in the field, but bonus use cases, right? Oil and gas exploration, intelligence, land management, insurance claims, disaster recovery, and use cases where users are asked to review large amounts of images and apply their human expertise. These are areas where they could certainly be helped and made more efficient and effective with artificial intelligence. Another one, telehealth. Whether it's remote, somebody calling in remotely and using their webcam, or maybe they're going to a satellite campus and they're having a specialist come in using local cameras and biometric devices and sensors and what have you. This is a growing field. And the interesting thing, it's not just the kind of images classification and pattern recognition that you would expect, but also another important area is natural language processing. You maybe have patients and healthcare providers that speak different languages, or they speak different dialects, or maybe they just have different ways of describing an ailment or problem. NLP helps with that. So this is a really good use case. But there's other analogous ones similar. So marketing, telesales, technical support, field services, dispatch, any application where the better understanding of human speech and behavior can be correlated with video, photographs, and other data. So there's a lot of use cases like this, and these, again, we think are great applications of AI workstations. Manufacturing, operations, and safety. So people on the floor, right, managing, maybe their safety, maybe their operations, but now what they're doing is they're looking at employee behavior, they're looking at safety, they're looking for behaviors that might be unsafe or harmful in the long run, and they're correlating that with IoT data and SCALA data from the plant and all this different data. And they're also applying, in addition to all the video stuff they're looking at pattern recognition, root cause analysis, predictive failure. So essentially, it's a brain for what's going on in the plant. So extremely useful. We think we'll see lots more examples of this. But analogous, use cases, facilities management, K through 12 higher ed, transportation, logistics, any operation where video needs to be correlated and interpreted with IoT and other types of data. So certainly, we think this is going to be a growing field. Another one, of course, public safety. So, TSA officers in airports, security officers in courthouses, any public building, large retail, what have you. Anywhere you have people, looking at lots of images. So the idea here is you go from a security officer looking at one or two, video screens to now being able to look at perhaps 4 of them, but also leveraging image classification and facial recognition, to map to known bad actors, pattern recognition, biometric monitoring, COVID-19, temperature, that sort of thing. So we'll see a lot of examples of this. And by the way, analogous, it's very similar to kind of brick and mortar retail for theft prevention or customer 360, traffic management. Smarter cities. Another one that we're getting interested in is casinos. Lots of different use cases like that. Anywhere you have kind of image classification and video analytics from video streams map with other, biometric and other types of data. And lastly, a really interesting one. I didn't know this, one of the most jobs in the world. The folks that monitor, inspect utilities transmission lines. It's somewhere around one of the 5 most dangerous jobs in the world. So these people now are starting to use drones, where the drones can go up there and inspect the lines because they have to inspect all of them regularly. And now they're using workstations to control. They can use workstations to control the drones, and then they'll be using image classification, pattern recognition, IoT, all that sort of thing right now, saving lives and improving the quality and lowering the cost. So kind of a win-win situation. And this is interesting. And it's analogous to other use cases, right? Insurance surveys, agriculture. This is what farmers are doing, right? This is how they're controlling fields. Insurance surveys. If you next time you go to renew your homeowner's insurance, you may have a drone flying over looking at your roof. Fisheries and wildlife management. Almost any use case involving drones. The interesting thing about the drone use cases, whereas earlier we talked about these edge use cases where you have the data on the server and that's communicating with the edge devices. This is a situation for these drones where you can have workstations that are out in the field, and they're the brains that are really communicating with these edge devices. So these are fairly interesting use cases, and I think in general it's kind of a nice way to wrap up, all the changes that are happening right now, but this whole idea of putting artificial intelligence into real work, right, in deployment. When you're ready to do that, we have a number of different ways you can do it. On the development side, we have 7,000 workstations, the 15-inch and 17-inch, the 7540, or 50, sorry, 7750, 5820, and the 7920 racks and towers, sorry. But this is another view of it, rather than, and sorry you don't get to have the pretty thick pictures, but for the most part, again, to kind of finish up for AI development, you're looking at, trying to accommodate, help data scientists and developers, plus now business intelligence, DevOps, DVAs, and all these other folks. From a Dell perspective, we think that our 5,000 to 7,000 line of either fixed or mobile workstations, very big